Properties of logarithms. Exponential logarithmic forms property. For example, log base 2 of 8 equals 3 since 2 to the third power equals 8. The equation log base 2 of 8 equals 3 is in logarithmic form. The equation 2 to the third power equals 8 is in exponential form. The forms log base 2 of 8 equals 3 and 2 to the third power equals 8 are equivalent. Here are more examples of equations in equivalent logarithmic and exponential forms. The logarithmic form log base 2 of 16 equals 4 is the same as 2 to the fourth power equals 16. The logarithmic form of log base 3 of 9 equals 2 is the same as 3 squared equals 9. The logarithmic form of log base 5 of 125 equals 3 is the same as the exponential form 5 to the third equals 125. The logarithmic form of log of 100,000 equals 5 is the same as the exponential form 10 to the fifth power equals 100,000. Properties of logarithms. The exponential logarithmic forms property. For a greater than 0, b greater than 0, and b not equal to 1, the equations log base b of a equals c and b to the c equals a are equivalent. The equation log base b of a equals c is in logarithmic form, and the equation b to the c power equals a is in exponential form. Either form can replace the other when you solve a problem. In this example, we want to write the equation in exponential form. Assume all constants are positive and not equal to 1. Part A, I have log base 5 of 125 equals 3. To rewrite this, first we find our base, which is 5. The exponent is what it's equal to, so I have 5 to the third equals, and it is equal to what's in the parentheses, which is 125. So 5 to the third power equals 125. For part B, I have log base k of t equals w. So I start with my base, which is k. It's equal to the exponent, so that's k to the w power, and it's equal to what's in the parentheses, which is t. So log base k of t equals w is the same as k to the w power equals t. In this example, write the equation in logarithmic form. Assume that all constants are positive and not equal to 1. Part A, I have 3 to the fourth power equals 81. So I start by writing log, and then my small number is always the base, which in this case is 3. I put in parentheses what it should equal, which is 81, and then that equals my exponent, which is 4. So 3 to the fourth power equals 81 is the same as log base 3 of 81 equals 4. For part B, I have p to the r power equals q. So I start with my log. My base is p. My parentheses, I put what it equals, which is q. And it equals the exponent, which is r. So p to the r power equals q is the same as log base p of q is the same as log base p of q equals r. Logarithmic equations. A logarithmic equation in one variable is an equation in one variable that contains one or more logarithms. In summary, for an equation of the form log base b of x equals k, we can solve for b or x by writing the equation in exponential form. In this example, we want to solve log base 4 of x equals 2. My first step is to rewrite this in exponential form. So I start with my base, which is 4. It's equal to the exponent, 2, which is equal to what's in parentheses, x. 4 squared is 16, so x is equal to 16. In this example, solve log of x equals negative 2. Since the base isn't written, we know that the base is 10. It's equal to my exponent, negative 2. 10 to the negative 2 power is equal to x, since x is in the parentheses. 10 to the negative 2 power is 1 over 100, so x equals 1 over 100. In this example, solve 4 times log base 81 of x minus 3 equals negative 2. Our first step is to isolate log base 81 of x. That way we can transform it. So I'm going to add 3 to both sides. 4 times log base 81 of x equals 1. Divide both sides by 4. Log base 81 of x equals 1/4. Now we're ready to rewrite it in exponential form. My base is 81. My power is 1/4. And that's going to equal x. Calculating, I have 81, 2, parenthesis, 1 divided by 4, power, enter, and I get 3. So x is 3. Power property for logarithms. An exponential equation in one variable is an equation in one variable in which an exponent contains a variable. Power property for logarithms. If x is greater than 0, b is greater than 0, and b does not equal 1, log base b of x to the p power is equal to p times log base b of x. In words, a logarithm of a power of x is the exponent times the logarithm of x. In this example, solve for b. Round any approximate solutions to the fourth decimal place. Log base b of 8 equals 3. One method we have to solve this is by remembering that 8 is a perfect cube. So I have log base b of 2 to the third power equals 3. I can use my power property to rewrite this as 3 times log base b of 2 equal to 3. Divide both sides by 3. I have log base b of 2 equals 1. I can rewrite this in exponential form. My base to the first power equals 2, which means b equals 2. In this example, solve for b. Round any approximate solutions to the fourth decimal place. Log base b of 16 equals 5. 16 can be written as 2 to the fourth power, which gives us log base b of 2 to the fourth power equals 5. So I can rewrite my log using the power property. 4 times log base b of 2 equals 5. Dividing both sides by 4, log base b of 2 equals 5 over 4. Now I can rewrite that in exponential form. B to the 5 over 4 power equals 2. In order to solve this, we have to get rid of our power. I can get rid of any power by taking it to its reciprocal power. So b to the 5/4 power to the 4/5 power will give me b to the 20 over 20, which is b to the first, which is just b. What I do to one side, I have to do to the other, so I have to find 2 to the 4/5 power. Calculating 2 exponent, parenthesis, 4 divided by 5, close parenthesis, gives us 1.7411011127. And we want to round this to 4 decimal places. So B equals 1.7411. Logarithmic property of equality. For positive real numbers a, b, and c, where b does not equal 1, the equations a equals c and log base b of a equals log base b of c are equivalent. In this example, we want to solve, round the solution to the 4th decimal place. 5 to the x power equals 97. Based on the logarithmic property of equality, I can take the log of both sides and it still remain equivalent. Because I want to be able to calculate this, I'm going to use log base 10. So log of 5 to the x equals log of 97. I can write my exponent in front. X times log of 5 equals log of 97. Now I can solve for x by dividing both sides by log of 5. X equals log of 97 over log of 5. Calculating log 97, make sure you close your parenthesis, divided by log 5, close your parenthesis, enter, 2.842427746. Rounding to the 4th decimal place, 2.8424. So x equals 2.8424. In this example, we want to solve and round the solution to the 4th decimal place. 3 to the 4x plus 2 power equals 341. First step, take log of both sides. Log of 3 to the 4x plus 2 power equals log of 341. Now we're ready to bring our exponent in front using our power property, which gives us parentheses 4x plus 2, close parentheses, times log of 3 equals log of 341. Now we can divide both sides by log of 3. So we have 4x plus 2 equal to log of 341 divided by log of 3. Calculating log of 341, close parentheses, divided by log of 3, which gives us 5.3084. For x plus 2 equals 5.3084. Subtract both sides by 2. For x equals 3.3084. Dividing by 4, x equals 0.8271. So for the equation, 3 to the 4x plus 2 power equals 341, x equals 0.8271. In this example, use intersect on a graphing calculator to solve the equation. Round any solutions to the 4th decimal place. 2 to the x equals 5 minus 2x. What we want to do is look at this as y equals 2 to the x power and y equals 5 minus 2x. and type those two equations in our calculator. Y equals, we want to type in 2 exponent x, arrow down, and then type 5 minus 2x. Now we want to go to Zoom, and let's choose 6 standard. Our blue line is 2 to the x power, our green line is 5 minus 2x. As long as we can see where they intersect, we'll be able to use our intersect function on the calculator. Second, trace gets me to my calculate menu. I want number 5. I'm going to arrow over to where they cross. Enter, enter again, enter. And my intersection x equals 1.2831506, y equals 2.433698. We're interested in what x is using our fourth decimal place. X equals 1.2832. Properties of logarithms. I can write log base b of a equals c as b to the c power equals a. That's our exponential logarithmic forms property. I can use this property to solve my logarithmic equations. If my x is in the position of a, all I have to do is rewrite the logarithmic form in exponential form, and then I can solve for x. If my x is in the position of my base, I can also rewrite it as exponential form and solve. The power property for logarithms says that if I have log base b of x to the p power, I can rewrite that as p equals log base b of x. The logarithm property of equality says that I can take the logarithm of any base to each side of the equation to solve. Using log of base 10 allows us to use our calculator to assist us in solving.